So we have a riddle for you. Okay, not really a riddle. We're bad at riddles, but more like clues about our favorite molecule. It's polar, it's shaped like an outstretched V, its properties are awesome, and it makes up 3/4 of the surface of the Earth. That one always gives it away. Our favorite molecule is water. We really want to talk about what makes water so unique for biology itself. What are some awesome properties of water? The fact that water is polar. It has one very electronegative oxygen that is always trying to keep the electrons closer to it than to the hydrogens it's bonded to. And this actually gives oxygen a slightly negative charge because of the electrons that are spending more time next to it, and it gives the hydrogens a slightly positive charge. Well, that means that other water molecules have an easy time bonding together. Why? Well, because the hydrogen of one water molecule with its slightly positive charge can bond to another water molecule's oxygen with that slightly negative charge. These bonds among the water molecules are hydrogen bonds, and these are the very bonds that allow water to have many of the properties that we're about to talk about. Have you ever looked at a really tall tree and wondered, how does the water get all the way up there? I mean, it's got to go against gravity. Gravity? Well, in our plant video, we talk about the xylem. It's vessels within certain types of plants, like trees, and these vessels transport water. But what's really neat about water is that it sticks to the xylem walls in what is known as adhesion. And this helps fight gravity. But water molecules with their hydrogen bonding, they also bond to each other in something called cohesion. It's almost a beads on a string kind of fashion. Water molecules evaporate from a leaf, and then the next water molecule in line is pulled upwards, and so on. This cohesion is really a big deal. Cohesion is also a reason that water striders, one of our favorite insect types, can skate on water. Cohesion contributes to the surface tension of water. Water actually has quite a bit of surface tension compared to many other liquids. And it's not just water striders that can walk on water. There are a lot of insects, spiders, and even larger animals like reptiles and some birds that have the ability to walk on water. So, to the Google for that. Now, with water being polar, it's also a very powerful solvent for other molecules. And that means that water can dissolve many other molecules, especially polar molecules and ionic compounds. Now, why does that matter? Well, this is really important because many of the processes that occur in organisms use water as a solvent. In our body system video, we talk about the function of kidneys, and you definitely couldn't have kidneys doing their function without water. Also, a main component for body fluids is water. I'll never forget when I was little, my father built us a pond. We had some goldfish in there, and I loved this pond. Well, in West Texas, where we're from, it can freeze in the winter. And one morning, I went outside, terrified to find that the top of the pond had frozen. And I thought our fish were goners. Only to find out that they were swimming and doing their fish activities under the ice layer. It's common for many substances to actually contract when they freeze and to become more dense. But water expands when it freezes and becomes less dense in its frozen state, resulting in floating ice, where it can actually make this insulated surface layer that makes a difference for many organisms underneath. And this is due to the hydrogen bonds. See, at freezing level, the making and breaking of hydrogen bonds, which usually happens pretty often, it's not happening very much when frozen. And so the molecules, they're set into this lattice of hydrogen bonded molecules, just far enough apart that it's less dense in ice form than it is in water form. And that's going to be very important for all of that aquatic life. Speaking of temperature, water resists changing its temperature. It has what's called a high specific heat. Specific heat, it's a measurement of heat that's needed to be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. And that's why on the first day that school is out in the summer, it may be super hot outside, but the water could still be pretty cool. It's really good that water's like this for life. It's stabilizing for aquatic environment temperatures. And it also means that water can absorb a lot of heat in the summer without reaching as high of a temperature itself, which is useful when winter comes along, because then the water can release heat as it cools in the winter. This also impacts the environment. Now, still on the topic of temperature, consider evaporation. Many animals rely on evaporation to cool them. Think of water molecules. They are moving, but those that have more heat energy, they're moving the fastest. And they're the more likely molecules to make the phase change to gas. And these molecules, as they leave, their energy, their heat, is no longer on your skin. And by the way, all of this is not just animals, too. Plants use evaporative cooling to aid them in hot temperatures. Excessive high temperatures could be very dangerous for many different processes in both plants and animals. It can be damaging to the enzymes involved in those processes. So, that evaporative cooling is very important.